A confused deputy is a type of security vulnerability. Let's say a caller interacts with Service A. Service A then calls Service B to complete the request and respond to the caller. Now, would it be possible for a malicious caller to exploit this trust that exists between Service A and Service B? For example, can the caller use Service A to gain excessive privileges and perform an unauthorized action in Service B? If this were to happen, Service A would become a confused deputy. In fact, there are many places where this issue can pop up in the cloud. I will discuss 3 common confused deputy scenarios within AWS and look at solutions to place appropriate safeguards. Let's look at the first scenario: third-party access to your AWS account. Let's say you hired a third party to audit your AWS environment security. The third party automatically and periodically reviews your environment and generates a report for you. So we have a customer account, that is our account, and the service provider has its own AWS account. We'll call this as a third party account. Now, the third party needs access to your account. And this type of cross-account access is granted using IAM roles in AWS Cloud. Here, we need to create an IAM role that can be assumed only by this third party, and then you share the IAM role name with the third party. The third party then proves their identity with AWS and assumes the role privileges granted by you to access your environment. The IAM role, in fact, has 2 separate components to it. It has a trust policy where we need to explicitly state the account number that can assume this role. In this case, we'll specify the service provider account number. And there is also a permissions policy that grants specific resource level access. This policy grants all the permissions that are needed by the service provider. So whenever the third party audits your environment, they will use this IAM role. I want to highlight that the IAM role name is not considered a secret. To prevent others from misusing this role, we identify the service provider account as the trusted entity within the IAM role. AWS security will ensure that only the service provider can assume this role. This approach by itself is pretty secure. However, let's say this service provider also audits many other customers' AWS environment. So there are multiple customer accounts now, and we have one service provider account that has access to all these customer accounts. The question now is, can another customer figure out a way to access your environment through this service provider? Now you might be wondering, how can this happen? Let's walk through one scenario. Remember, the customer creates an IAM role and shares the role details with the service provider. Now let's say customer B used social engineering skills to find out what role you created for this third party. And then customer B asks the service provider to use your IAM role. Now when a service provider assumes this role, which they will be able to do as you already granted them trust privileges, the service provider will gain access to your environment. But the problem is, the service provider thought that they were accessing customer B's environment. The audit details of your account will now be shared with customer B. Here, customer B tricked the service provider into accessing your environment and gained access to the audit report. The service provider here became the confused deputy. Now you might wonder why the service provider can't check the account number of the customer and detect a mismatch in the account number specified in the role ARN. The problem is each customer could have many different AWS accounts. So a customer could use a common account to configure the service provider and specify IAM roles for individual accounts. So we need some mechanism other than just the account number to verify if the customer indeed owns the account they are configuring. To protect from this confused deputy scenario, the service provider must now assign a unique customer ID for each customer. And then the service provider must share the customer ID with the respective customers. In the IAM roles trust policy, we need to add a condition and verify if the customer ID sent in the request matches with the customer ID assigned to your account. Now, from service provider perspective, when they assume the role, they must also specify the customer ID in a special variable called external ID to gain access. Let's see how the external ID protects us from confused deputy problem. Customer B once again provided your IAM role name to the service provider. The service provider now thinks that it is accessing customer B's environment. So it specifies customer B's unique ID when assuming the role. Now the external ID provided by the service provider would not match the external ID that you configured in your IAM role, and the access is denied. So when granting third-party access to your AWS environment, always configure the external ID as part of the IAM role. The external ID needs to be unique and provided to you by the third party that needs access to your environment. Let's now look at one more scenario. This time it involves two AWS services. Let's say a client publishes a message to SNS topic, and SNS topic in turn broadcasts the message to all subscribers. And one of the subscribers is an SQS queue. This approach is widely used in loosely coupled architectures. And for this to work, SNS topic needs permission to publish to SQS queue. This permission is granted as a resource-based policy in the SQS queue. Let's say the policy looked like this. Let me unpack the policy. We are granting permission to SNS service to publish messages to SQS queue. So the principal here is the SNS service, and it is communicating on our behalf with SQS, which happens to be another AWS service. The allowed action is SQS send message. And in the resource ARN, we identify the specific queue where we want to send the message. So with this policy, SNS topic can publish messages to the specified queue. However, the problem here is we granted permission to the SNS service itself. So what this means is any SNS topic can publish the message to your queue. This includes SNS topics in other accounts and regions as well. This issue is also a confused deputy problem, as someone can use the intermediary, in this case SNS service, to perform an unauthorized action, which is publishing messages to your queue. To prevent this scenario, we need to explicitly verify if an authorized SNS topic is sending the message. So what we can do is, we need to include a source ARN variable condition and check if the request indeed came from an SNS topic belonging to our account and region. AWS automatically provides this variable in the request. So with this check, we added a condition that included verifying the source ARN and made sure the request indeed came from our topic. AWS recommends that we use source ARN when granting service-to-service access and limit the service permissions only to a specific resource. Let's now look at our final scenario. This scenario involves S3. Let's say we want to be notified of any new objects in the S3 bucket. So we configured S3 bucket notifications to publish a message to SQS queue. So we can grant this permission to S3 using SQS queue resource-based policy. So here our principal is S3 service. And we also identified the specific queue in the resources. And then we also applied the learnings from our previous scenario and specified the source ARN to verify if the request indeed came from a specific bucket. This particular policy will work and ensure the request comes from the specified bucket. However, the problem here is we are not checking if the bucket indeed belongs to our account. The S3 bucket ARN looks like this. The region information and account ID are missing here. This is probably due to the legacy nature of S3 and also because the bucket name is globally unique. So AWS thought they could figure out which account owns the bucket and the bucket region by just using the name. This particular ARN convention is bad from a security perspective. Now, what if the account owner deleted my bucket and another customer created a new bucket with the same name? Since we don't have account ID or region name in the bucket ARN, if you look at the ARN of the new bucket, it will exactly match with the old bucket name. The problem is we now have a potential security issue because your SQS queue would now allow messages from this new bucket. Now, to protect from this possibility, in addition to the source ARN, we must also add one more check to verify the source account. This check ensures that the request came from my bucket and then the bucket indeed belongs to the specified account. I hope this video clarifies what a confused deputy problem is and how we can protect our resources by adding a conditional check using external ID, source ARN, and the source account. A trusted account and external ID are configured when you grant a third party permission to access your AWS environment. The source ARN and source account are more commonly used when configuring permissions for AWS Service-to-Service interaction. If the source ARN includes the account ID, we don't have to check the source account. However, if the source ARN does not contain the account ID, we must also check the contents of the source account variable. Thank you for watching, and if you like this video, please subscribe and share it with others. If you want to learn more about AWS security, check out my security specialty course. I have provided the link to the course in the video description. Thank you.